Welcome to day 70 of our school year. Completed another row. Okay, let's get down our beginning fraction. We have a total of 180 school days. We are on day 70. So we need to find the factors of our numerator, which is 70. Two numbers we always know are 1 and the number itself. Using the commutative property of multiplication, I can also write 70 times 1. Now I'm going to go through my divisibility rules in order so I don't miss any possible factors. So after 1 in order would be 2. The rule for 2 is that it ends in an even number. 0 at the end of a number is an even number, so 2 is a factor. Half of 7 I can't do, but I can do half of 6 tenths is 3 tenths. That leaves a 10. Half of 10 is 35. Okay, we can add the digits together. That's the rule for 3. 7 plus 0 is 7. 7 is not a multiple of 3, so 3 is not a factor. We try 4. One way to check for 4 is if the second factor with 2 is even. It is odd, so that means 4 is not a factor. We try 5. It ends in a 0 or 5, so 5 is a factor. 5 times 14, because I can get 10 groups of 5 out. I'm left with 20, and that would be 4 groups of 5. And 14 times 5. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, 3 is not, so 6 is not a factor. We try 7. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Yes, 7 is a factor. 7 times 10, 10 times 7. We only need to check the counting or natural numbers between 7 and 10. So that would be 8 and 9. Let's see, 8, 16, 24, 32, 40, 48, 56, 64, 72. 70 is not in that list, so 8 is not a factor. 9, the rule is the same for 3. When we add the digits together, we get 7. 7 is not a multiple of 9, so 9 is not a factor. We get to 10, and we are done. Let's go ahead and list our factors from least to greatest. 1, 2, 5, 7, 10, 14, 35, 70. Since we have 8 factors, is this prime or composite? It is composite. Now we need to figure out what our greatest common factor is. Let's start with our greatest factor of 70. Your group of 70 does not have to look like mine. Just keep your shaded separated from your unshaded, because otherwise you're dealing with fractions inside fractions. So I have 40 left over. That means that 70 did not work. It's not a common factor. You can't have any remainder, anything left over. Let's try 35. 30 and 5. 5 and 30. 30 and 5. 5 and 30. 30 and 5. And we have 5 left over. A remainder of 5. So that means that 35 did not work. Let's try groups of 14. So your groups of 14 do not have to look like mine, but make sure there's 14 in each and that you keep your shaded separated from your unshaded. So I have 6. 8 plus 6 is 14. 4 plus 10. 10 plus 4. Using that decomposition can help, but if you need to count, that works too. Let's see, I have 6 plus 8. 12 plus 2. 8 plus 6. 4 plus plus 10, 10 plus 4, 6 plus 8, and then I have 12 left over, so 14 didn't work. Let's go ahead and make our groups of 10. Let's make our groups of 10. Those are nice and easy. Since each row is in groups of 10 already, I can just show my rows. All right, finally we found our greatest common factor. 10 worked. Yay! So let's count up our total groups of 10. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 total groups. And I have 1, 2, 3, 4, 5, 6, 7 shaded in. Now that I've done my division with my model, I'm going to go ahead and do my division with my algorithm. Divide into groups of 10. Okay, so let's use our algorithm. Divide into groups of 10. So 180 and 70. So I know 10 times 10 is 100. Numbers the same, zeros the game, more on top, no need to stop. And 8 times 10 is 80. Numbers the same, zeros the game. Add the partial quotients. 10 plus 8 is 18. Here, let's see, 5 times 10 is 50. Numbers the same, zeros the game, more on top, no need to stop. 2 times 10 is 20. Numbers the same, zeros the game. Add our partial quotients. 5 plus 2 is 7. Now you may have already figured out that 18 times 10 is 180 and 7 times 10 is 70, and that way you got to the answer more quickly. But I just want you to see that there's more than one way to get to the right answer. But we do need to check with our inverse operation. Divisor times quotient plus remainder, divisor times quotient plus remainder. Since our remainder is 0 for both, and the identity property of addition says when you add 0 it stays the same, we don't need to add 0. Our placeholder moves it over a place. One group of 8 is 8, one group of 1 is 1. Our placeholder moves everything over a place. 1 times 7 is 7. So 70, that matched up here, so check. 180, that matched up here, so check. Our numerator is definitely 7, and our denominator is definitely 18. All right, let's go ahead and fill in our data collection page. Okay, we are on trimester 2, week 3. Today is 11, 18, 19, and our fraction for today is 7/18. We did groups of 10. Let's go ahead and get out our number line. Okay, and our last one is 5/18. So next we have 6/18, 6 pieces out of 18 pieces. We have lots of equivalent fractions to this one. 10/30ths, 12/36, 15/45, 20/60, 30/90, and 1/3. That's the simplest form. Our equivalent fraction in lowest terms. And then today is 7/18. There are no lines below it because it is our simplest form, or our equivalent fraction in lowest terms. But there is an equivalent fraction in the 5s and the 2s, because 5 and 2 are both common factors, but 10 is our greatest common factor. Go ahead and put your number line away, erase your worksheet, and thank you for joining me.